I'm going to show you dt, vt, and at graph of an object in free fall. Free fall meaning you are on the top of a building which is 80 meters above the ground, standing on the top of a building and dropping a marker. How long is supposed to take? How the dt, vt, and at graph supposed to look like when object in free fall, when you drop something. And dropping by definition meaning initial velocity is 0. Dropping means letting it go. Okay. So first we have to make a table, and then we'll use the table to draw dt, vt, and at graph. Okay. The scenario is you are on the top of a building, and the building is 80 meters tall. Okay. So we're going to use this to draw dt, vt, and at graph. So let's get it started. First, we're going to write table. So I have t here, which is in second. I have d here. This is a displacement, which is in meter. And I have a distance. I have a distance. Understand the difference between displacement and distance. Okay. So meter. Velocity, meter per second. And the acceleration, meter per second is squared. Okay. So I'm going to do 0 second, I'm going to do 1 second, I'm going to do 2 second, I'm going to do 3 second, and finally I'm going to do 4 second. All right. 0 second. For this one, I'm going to use a different color. I'm going to use red. So D M. Displacement, I'm going to use red. Okay, so the formula I'm going to use is d is equal to vit plus half at squared. Now, as I told you, when you drop something, the initial velocity is 0. So you drop that from the formula. So your formula is half at squared. Now today, for simplicity, we're going to the acceleration due to gravity is negative 9.81 meter per second squared. But for simplicity, we're just going to use negative 10 meter per second squared. We're going to round 9.8 to the nearest whole number, which is 10. Okay. So if you do, so at 0 second, of course it is 0. All right. The ball is still, the marker is still on your hand, or whatever it is, the ball or the marker is still on your hand at 0 second. Makes sense. At minus 0 is at. Okay. What about at 1 second? Let's plug in 1 over here. So if you write d of 1 is equal to half negative 10 and 1 is squared, then you get negative 5. Negative 5 meter. You get negative 5 over here. At 1 second, you get negative 5. 80 minus 5 is 75. At 2, negative 10 and 4. So you should get negative 20. So 80 minus negative 20 is 60. At 3 seconds, you get negative 45. So 80 minus 45 is 35. At 4 seconds, you get 80. How do you get 80? I'll show you right now. D is equal to half negative 10, 4 squared, which is 16. 8 times negative 10 is negative 80. So the building is 80 meter tall minus the ball is 80 meter away from your hand. Does that make sense? The ball is 80 meter when you let it go. This is top of a building, 80 meter above the ground. After 4 seconds, the ball is 80 meter away from your hand. So 80 minus 80 is equal to 0. That means the ball is at the ground. Makes sense. Now we're going to do the velocity. To do the velocity, here's what we're going to do. This is the equation we're going to use for the velocity. velocity is meter per second. So velocity final is velocity initial plus at. Velocity final at 0 second, of course, velocity is 0. Of course, that makes sense. At 1 second, let's see. When you drop something, initial velocity is 0, which I explained at the beginning. -10, acceleration due to gravity, and 1. So this is -10. This is -20, because at 2 seconds, at 3 seconds, -30, because this is you multiply by 3. At 4 seconds, this is -40. Now, we're going to do the acceleration. Acceleration is constant. Acceleration due to gravity is constant. Okay? So you're going to write -10, -10, -10, -10, and -10. Now we are ready to draw dt, vt, and at graph. And let's see how that. So, this is our dt. Okay? This is our vt. And this is our at. All right, so to do the dt, we can use more space. All right, we have how many? 1, 2, 3, 4, 1, 2. Okay, so this is 0, this is 1, this is 2, this is 3, this is 4. So the time is in second. And this is 20, this is 40, this is 60, and this is 80. Distance is in meter. You are here standing up 80 meters above the ground. It starts from here. So 0, at 0 second, you are at 80. At 0 second, the ball is at your hand, which is 80 meters above the ground. Makes sense. So at 0 second, it is over here. Okay, makes sense. At 1 second is 75. Ball is not at your hand anymore. It's 5 meters away from hand. It's 5 meters away from your hand. So at 1 second, the ball is here. At 2 seconds, ball is at 1 second, ball is 75. At 2 seconds, 60. At 2 seconds, 60. At 3 seconds, 35. 35. At 4 seconds, ball is at ground. So this is the dt graph. This is the dt graph when you drop a ball, or when you drop anything. You drop apple, you drop hammer, you drop feather. This is the dt graph. You just drop it, and this is the dt graph. You drop it from a rooftop or from any given height. This is how you drop it, and this is how the graph should look like. You drop it here on the earth. If you drop it on the moon, that's a different story, which will explain it in a second. Now, let's see how the VT graph should look like. Now, let's draw whatever we have. So this is the t in second, and this is velocity in meter per second. All right. So you have time, 4 seconds, 0 second, 1 second, 2 second, 3 second, and 4 second. Okay. And you have -10, -20, -30, and then -40. Okay. At 0 second, the velocity is 0. That makes sense. At 1 second, velocity is -10. That makes sense. At 2 second, velocity is -20. That also makes sense. At 3 second, velocity is -30. That also makes sense. 4 second velocity is, so you're going to connect this dot. So this is the velocity versus time graph for an object. That is in free fall. Now let's see how the acceleration would look like. So this is our AT graph. This is our acceleration, meter per second square, and this is our time in second. Of course, this is 1 second, 2 second, 3 second, and 4 second. And we're gonna have -10, and we're gonna have +10. At 0 second, acceleration due to gravity is -10. At 1 second, acceleration due to gravity is -10. At 2 second, acceleration due to gravity is -10. Acceleration due to gravity. So we can conclude that acceleration due to gravity is constant. We also can conclude that velocity, VT graph, is linear. We can conclude that DT graph is a second degree polynomial, quadratic. Now, what remains is to prove that how it is quadratic. Remember, we use this formula. D is equal to VIT plus half AT squared. Now, next 5 to 10 minutes, I'm going to show you the proof of this one. Is actually nothing but a second degree polynomial. Okay, so let's do it together. We're gonna use 3 points. Point number 1, point number 2, and point number 3. These 3 points we're gonna use. These 3 points I'm talking about, folks. So let's use them. Step 1. I'm gonna write a step because there are 5 to 6 steps. So I also want you to write the steps. Step 1. Remember, our goal is to prove that this equation, the kinematic equation, is nothing but a second degree polynomial. Okay? That means this is nothing but y is equal to -ax squared. Am I right? That's what we are heading to. Y equal to -ax squared should look like this. We have a red, we have a black part, and we have a red part. This is the red. And this red part and this red part is exactly same. The difference between this red part and this red part is this one origin is 0, 0. Because this one is at ground. This one origin at 0, 80. You just take it and put it over there because you are on the top of the building. Alright, that's the difference. So there is no difference between this one and that one. Okay, so I want you to give that idea. I want you to make sure you understand it. Now, since you understand it, we want to show the proof. And here's how it goes. So step 1, y is equal to ax squared plus bx plus c. All right. So our first point is 0, 0. That's what you're gonna use, 0, 0. So that y is 0 is equal to x is 0. This x is 0 plus c. So c is 0. So we got 1 point. So we're gonna write what we got, 0. What else? We're gonna write this equation again. Y is equal to ax squared plus bx plus c. Here we use 0, 0. Now we're gonna use 1, -5, 1, -5, 1, -5. So -5 is equal to a plus b. the system of equation, and that's what we want. So I'm going to write that over there. Okay, so I'm going to just box it, and then I'm going to erase this because I need some space. We're going to write y is equal to ax squared plus bx plus c. Now the next point, I'm going to use the point number 3, 2 comma negative 20. So I'm going to write 2 comma negative 20 over here. Okay, so here is negative 20. Here is 2. The 2 goes to 4a plus.
Yes, I'm closing.
Give me 5 minutes, please.
All right, yeah, hurry up. It's 10 o'clock.
Okay.
Lock up the
Okay.
building,
this is 4. Okay, so the b is 2b. All right, so this is 2b. Now we have system of equation. This one and this one, we're going to put them together. So negative 20 is equal to 40a plus 2b, and this one we're going to write 4a plus 2b is equal to negative 20. A plus b is equal to negative 5. Okay, so we're going to multiply it by negative 4. If we do multiply it by negative 4, then what do we get? We get 4a plus 2b is equal to negative 20. And then what do we get? Negative 4a negative 4b is equal to 20. So this cancels, so I have negative 2b is equal to 0, so b must be 0. So c was 0, b is 0. What left is to find the a. So plug the value over here. A plus b is equal to negative 5. So then a plus 0 is negative 5. So a is negative 5. So a is negative 5. So we're going to write a is negative 5. So we're almost there. Now we're going to write the formula again. We're going to write the formula, and I'm going to write it here. The formula is y is equal to ax squared plus bx plus c. This is the second degree polynomial, and we said that this one is equal to this one. Okay, so let's see how. A is negative 5 x squared plus b is 0 and c is 0. So y is negative 5x squared, and that's what we said in the beginning. Let's have two vectors. Vector A, which is 3 meter, and vector B, which is also 3 meter. What I want to do, I want to add A plus B. We want to do it many different ways. By geometry, by trigonometry, law of cosine, and law of sine. So number 1, geometry. Number 2, trig. Number 3, law of cosine. Number 4, law of sine. So let's first do with the geometry. So I'm going to draw the original vector again. So my vector A is this one, and my vector B is this one. Okay. Alright, now what I'm going to do, I'm going to shift my vector A, which is 30 degree from the origin. This is 30 degree. From the 30 degree from the x-axis. So I'm going to draw this one here. Same vector. Okay, so I can erase this. Alright, now this one has two components, y component and x component, this red one. And the green one is 3 and the red one is 3. It's because green one is 3 and this red one is, as you see, I wrote 3 over here. Okay. This 3 will have two components, y and x. If this is 30, then this must be 60. So this is 60. This is 90. So this must be 30. So what do we know about 30, 60, 90? This is 2a, this is a square root of 3. So 2a is equal to what? 2a is equal to 3. So a must be 1.5. Okay, so this is 1.5. So this must be 1.5. Now let's find the x component. So x component is a square root of 3. A is 1.5 times the square root of 3, 2.6. So this is 2.6. Now what I basically have is x and y. So x squared plus y squared. So x squared is 2.6 squared plus y squared is 3 plus 1.5, 4.5 squared. And that gives you 5.2 meter. And the angle is tangent y over x. So tangent y is 4.5, x is 2.6. So tangent is 60 degrees. Alright, now we're going to use the trigonometry. So trigonometry, I have two vectors. Vector A and vector B. Vector A has two components, as you know that. This is 3 cosine 30 degree, 3 sine 30 degree. Vector B has two components. 3 cosine 90 degree, 3 sine 90 degree. This is 2.6, this is 1.5, cosine 90 degree is 0, so this is 0, sine 90 degree is 1, so this is 3. So a plus b is ax plus bx, ay plus by. Ax is 2.6 plus bx is 0, 2.6, and that's exactly what it is, 2.6. Ay is 1.5 plus 3, 4.5, and that's 4.5 you see over here. It's a magic, 4.5. So now what do? You do the same thing. 2.6 squared plus 4.5 squared. You get 5.2. You're done with the trigonometry. Now you're going to do the law of cosine. So I'm going to erase the trigonometry to do the law of cosine. So law of cosine. So law of cosine said that c square is equal to a square plus b square minus 2ab cosine c. Okay, so now we're going to draw this. Where do our a plus b? So our a plus b is this one. This is our a plus b. This is our a plus b. Okay. So now, if this is 60, this must be 120. So I'm going to draw this over here. And this is 3. This is 3. So I'm going to draw this one, 3. I'm going to draw this one, which is 3. And I'm going to draw this one, which is a plus b. And I'm going to draw this 120. So I can draw this one nicely. Okay. Then this must be 30, this must be 30. Okay, so let's use the law of cosine. C squared is equal to a squared plus b squared minus 2 cosine 120. So c squared is 9 plus 9 minus 18. Cosine 120 is negative 0.5. So c squared is equal to 27. C is the square root of 27. So c is 5.2. Now we're going to do it by law of sine. So law of sine said a over sine A is equal to b over sine B is equal to c over sine C. If you have a triangle, if you have a triangle, this is A, this is B, this is C, then this must be big A, this must be big B, this must be big C. Okay, so we want only, to solve this problem, we want only 2. So any 2 we can choose. Let's choose this 2. A over sine A is equal to C over sine C. Okay. We want to find C. This is C. This is unknown. We want to find this. So this is C. We know A. A is 3. 3. If A is 3, what is the angle? 30. C, we need to find C. Sine C. So where is our C? C is this one. So then it's 120. So C sine 30 is equal to 3 sine 120. C is equal to 3 sine 120 over sine 30. So C is equal to 5.2. This is called magic.